Swayam Prabha. Digital India. Educated India.
Today we'll begin with sources of air pollution. Okay. So, when I say sources, broadly these can be classified in two groups. One is natural and the other is anthropogenic. Okay. Anthropogenic, we can also call this as the sources of air pollution which are more man-made. Okay. When you talk about the natural sources, okay, let's take some examples. If you can remember, emissions from volcanoes cause a lot of emissions. So are the forest fires, there could be other sources like dust storms, there can be the natural sources of biogenic source, like the plants. You see, the plants sometimes emit the hydrocarbons from there. You might have heard about Smoky Mountains. Okay. So these are some examples of the natural sources. The natural sources, if one quantifies, sometimes they can be quite large and the amount can be very, very significant. But when it comes to the anthropogenic or man-made sources, we can further classify them in 4 categories. We all know that industries cause serious problem. So there can be industrial sources, then vehicular or automobile, there can be domestic sources. Largely, we know we all do cooking in the home, and whatever fuel they may use, or you may use a very clean fuel like LPG, but that still cause some amount. Well, amount can vary on depending on the fuel that you are using, can also cause the problem which is associated with the domestic. Okay, so let's call it domestic sources. And the other sources which we sometimes refer to them as are the area sources, which we can club them, put them together in an area what sources are taking place, which may be sometimes a mixture of many sources. Okay. So we'll talk about these sources in this lecture and the coming lectures. But these again, if whatever you might think these sources are really, they can further be divided, okay, in two components, okay, each one of them. Okay, and a very interesting category for these two. Why interesting, as we will see in a moment. One is a regular or process related emissions, okay, and the other category can be what we call as fugitive sources, or sometimes also referred to as non-point sources. Okay. We'll go into the specific details of this, but their regular sources are more through chimney or a defined duct or a vent through which the actual emissions are taking place. So, these are the regular sources through stack, if I can use the word, or even you can also think of the tailpipe emissions. What it really means is the sources which are channelized and emitted like a regular source. Fugitive sources or the non-point sources are those sources which do not necessarily go through, or which do not in fact go through the chimney or through the regular means. One simple example, as I am teaching you, is I will give you example straight away of the fugitive source. As I am writing here, there is a little bit of dust from this chalk is generated, and this chalk, no matter how small is the emission, this can also be referred to as the fugitive sources. So, we will get into these specific things as we go by in this lecture, but let us talk a little bit about the fugitive sources or the non-point sources, because sometimes they are of great significance, not only great significance, but they can be of a major contributor, and sometimes we do not even know that problem exists. We keep on looking at the tall chimneys and think, oh look, there is a pollution, but sometimes these little tiny sources can be a major contributor, and in fact they are the one which largely sometimes may decide the air pollution or the air quality that we are breathing in. So, we need to understand these very well apart from the sources which we see in the regular pattern. Once we move before to the fugitive sources, let us also talk as to why we are not putting so much of stresses on the natural sources, whereas the natural sources can sometimes be in quantity can be very high. Why is this? That normally these emissions may be large, okay, but in sense of the local air quality, what people breathe, okay, these sources are not so contributory at the local level. What I mean to say is that suppose there is a volcano which is likely to erupt or which is very active, there won't be many people living in that around area. So is in the forest, that many people will not be there. And but these sources, okay, which are more man-made, they are occurring in very vicinity where we live. Okay. We live, the industries we can see, the vehicles will be all around us, the domestic cooking, well, we can't live without food, so that would be there, and so will be other small tiny little sources that would be continue to be there. So, we tend to put more emphasis on these sources rather than putting the emphasis on the natural sources. Of course, they do have significance in terms of the global sense, okay, but when we talk about local air quality, these sources are far more important than the sources what we see in the natural category. The other issue, of course, which is technological limited or engineering limited problem, because these sources there is very little we can really do to control them. I mean, there is no way that I can control a volcano and its emission. Okay. So, when the engineering solutions are not there, then it becomes extremely difficult. So is the forest fire. Okay. So, then keeping the focus on man-made, and within man-made what generally people tend to ignore is the fugitive sources or the non-point sources. Let us talk about the fugitive sources, because that is a tendency to ignore. Not even many textbooks would like to would like to cover this because that's where we see and that's where we tend to recognize these are the sources. So let's talk about the fugitive sources. What I would do is to make a little sense of the fugitive sources, I'll start writing some of the sources of the fugitive emissions. Okay, so that we get a little feeling that these fugitive sources are lot many, okay, sources which specifically we are talking about as fugitive sources, fugitive or non-point sources. For example, paved or unpaved road. We all see the vehicle moving on the road. Of course, there is emission from the vehicular tailpipe, but as it travels on the road, the dust which is there on the road, or the dust because of the friction between the tire and the road, cause lot of emission. Okay, so that could be one example of the fugitive source. We also see every time the building construction activities. So building construction, and you see the way the contractor and the people spread all the building material all over, the little wind blows and there will be dust emissions. Okay, the building, not only the construction activities, it's also the building demolition. That can cause serious air pollution. Let's also take some more example. We say the loading and unloading operations. Again a simple example, the construction activity is going on or industrial activity. Suppose somebody is loading the cement bags and you see the emissions everywhere. Okay, so loading is just an example, but loading and unloading can be related to anything. Unloading can be related to organic solvent. Organic solvent is being transferred from one container to another and there will be emissions of volatile organic compounds. So we should always be thinking the loading unloading operation can also give the serious, and we will see a little later how the loading unloading can be a serious issue. Let's also look at the agriculture activity. For example, I'm just writing as they come to my mind, and in fact anyone can little bit think, be a little observant, go around and see what are the sources. Okay, and of course there is no way one could completely list down all the fugitive sources. It's just matter of your own observation, seeing the things, observing things and making sense. Look, this is causing serious air pollution problem. Okay, agriculture activities. You must have seen the farmer spraying the urea, for that matter, okay, or they are plowing the field, or in fact they might be spraying the pesticide. Okay, see some of the pesticides, in fact many of them are volatile. As he's spraying the pesticide, this pesticide become volatile and they become part of the emission in the as a part of the air pollution. So these activities, okay, as I given this some example, let's write one at least so that we can remember it. Spraying of pesticides rather. Well, we can take some more example. Refuse burning, very common problem in most of our cities. There's a refuse people collect the garbage, their house or even some of the industrial units will cover some of the garbage, and what they would do is put it outside, set it on fire, and they think this is the best way of disposal of that. It causes serious problem as far as the air pollution is concerned, and this all will fall into the category that we are trying to emphasize on is the fugitive emissions. Okay, so refuse burning, even this the little ordinary stuff we do is all the leaves that fall from the tree from the fall period or during the basant time, we'll collect them together, okay, set it on fire. Okay, leaf burning, if we can also see. See, many of the cities in our country, they don't have the proper disposal of municipal solid waste. We can also refuse, also we can refer to this as, I'll write the short form as MSW, municipal solid waste. So what they would do is that, well, they can't dispose it of. If they don't dispose it off, it's going to degrade, it's going to cause a lot of emissions in terms of bad smell and things like that. Sometimes the people find it easy to set it on fire, okay, without knowing, and that this also causes serious air pollution. We also have seen in the winter time people burning the tires, for example, to heat themselves up. So these all will come under the category of the refuse burning. Let's take some more examples. I could also say the smoking, okay, can also come into this category of the fugitive emissions. Okay, the cigarette smoking, for that matter, that also would come under this category. Let's see if we can remember some more of the fugitive sources. Okay, if you go in the industrial plant, material handling, well, to some extent we cover that in the loading and unloading, but material handling can be a serious fugitive emission. Not only the material handling, even material storage. What I mean by storage is that, suppose you are storing coal dust, the coal which you are going to fire it somewhere, and then the conditions are like summer condition, lots of wind, and you will see a lot of coal being emitted in the air. So even the storage can be a major issue. Okay, some more example. Let's fill up this board with examples. Material handling, storage, smoking, refuse burning, agriculture activities, loading, unloading, and things like that. We should also not forget the emissions that may come out from the industrial area, from the leakages. Leakages of what? There could be valves which may leak. There could be joints that leak and cause air pollution. There could be flanges that can cause serious problem. Okay, so I can, it's just matter of again repeat that again it's so difficult to write down all these things. It's a matter of one being smart enough to observe these sources, okay, and to say, well, these are my sources. The another example I'll give you, which was very interesting, was the source emissions from lawn mowers. Okay, sometimes the huge gardens, the parks, and the people are, you know, like cutting the grass, and they use the lawn mowers which are like engine and motor driven, and then see a lot of emissions occurring from there. Okay, and this most of the time it is found the lawn mower engines were that of very bad quality, and sometimes the emission can be very, very large. We will a little bit get into the more of these things with a specific to an industry to give you more feeling about the industrial non-point or fugitive emissions. But let's also see as to why we are putting so much time and efforts in trying to understand the fugitive emission. Okay, I can also add some more important emissions of the fugitive emissions. Okay, what could these emissions really be is the emissions related to auto exhaust. What I mean by the auto exhaust is a tire which is on the road, there is a tire wear. So whatever is inside the tire, that can also come out. Okay, so that can be another significant source. I can also give you some more the idea about the emissions or the non-point emissions from the for example, sewage treatment plant. Okay, we all know the wastewater treatment takes place, and the wastewater treatment plants are the good source of H2S. They are the good source of the volatile organic compounds and the odor causing substances. So it's just a matter of you yourself realizing that what the source is. So before we go a little bit more into the details of this one, let's see what is so significance of the non-point sources. Okay, the significance, one of the most important thing about the sources is most of the fugitive emissions will be at the nose level, if I can say that. Means wherever you are there, the emissions are at just this height, the breathing level height. So it can, you would be likely to breathe that emission much more than probably the emission which is occurring from chimney or from the tall stack. Okay, so this is what is the level. So nose level means the impact is high. Okay. The other major problem is the not taking them seriously, not taking the cognizance, not taking cognizance is not taken. The problem is that we are born with the sources. As we have grown up, we have seen those things to be there. So we don't find them anything different than what we see it every day. So we don't even recognize them, don't even take them seriously. The cognizance becomes very difficult. Okay, we have the tendency to look something at the chimney and we say, oh, that is a problem. Okay, so we have to take the serious view of the fugitive emissions. The next thing is that what is the other importance of this thing is the quantification of these sources is a little difficult because they are occurring in a large area and you don't know where to really go and measure and say so much is the quantity of the emission, because for the controlling the emission, first you need to know is how much is the emission. So quantification is difficult. The other thing is poor regulation for the control of these sources. The laws, okay, the environmental laws more pertain to chimney, more pertain to larger sources, and no one would talk about some dust being emitted. Okay, so there is no regulation. So if there is no regulation, the industry, the people don't take it seriously. So we have to have good regulation to even to talk about the fugitive emissions. Let's also talk some more importance. See, as you have learned and you will learn, that idea of once we have the emission is to see how they disperse, okay, and how they go and impact the people. So that is what is a process of describing the emission, its transportation, and its impact to the people. That's what we call as a modeling. So when the sources are not so well defined, okay, so that becomes the modeling or to finding out the impact becomes very difficult. Modeling means I am referring to the air quality modeling is not difficult, but let's use the word difficult. So that's difficult. So that's what is another problem. And in my opinion, the major problem with this one is in a cumulative sense. They may be small 5,000 sources and we don't take it seriously. Put them together, they may be larger than, for example, a large power plant. Okay, so in a cumulative sense or in the total sense, okay, it's very important. Okay, we would now, what we would do is, as we are discussing these sources, very quickly I'll write few points that what we can do to control these sources. Control, okay. We'll talk simple options, okay, and what these simple options are. What it really needs is good housekeeping. Okay, keep the things clean. Okay, don't let such thing happen. Good housekeeping means you are constructing a building, you have all the building materials, cover the whole area, so those emissions are not going out. Okay, if possible, the other options can be, if possible, maintain little moisture level in the raw material that you are handling. That's a big help. Maintain moisture in material that you are handling. Well, I am not saying necessarily maintain moisture in everything that cannot contain the moisture. For example, well, you are handling a cement, let's say, and I am not saying that please maintain some percent of the moisture in that will be disaster. Okay, they maintain the moisture in the metal handling. Okay, regular checks of your flanges and walls, because sometimes these fugitive emissions are simply not the pollution, it is your own resources, your own raw material, your own product. If that is being lost, then well, economically you are doing a very poor job. What else can be done? Channelize them if you can somehow. If you channelize them, there is a good possibility that it can be controlled. Channelize the emissions. Enclose the area where you are doing such operations. Enclose the area. Simple thing. More options you have is provide what we call as a windbreakers. Something that will slow down the speed of wind. As a result, the emission from your storage area will sometimes go down. Provide shelter belts. Okay, I'll explain you what shelter belt is. Shelter belt. Shelter belt is smartly putting the trees around the area where you are likely to have the emission. Shelter belt is largely, you can say, the tree growing of the tree around operation where you have this serious problem. Shelter belt or planting and growing trees around the planting and growing trees around. Some of you might have gone to Taj Mahal now or some 20 years ago. There was no trees and there was no forest area. In fact, a very important decision was taken to grow lots of trees around Taj Mahal so that some of the pollution will be prevented by the trees that goes in there. Trees, not necessarily I am saying the trees will absorb the pollution or trees will filter the pollution. What really happens is that the pollution, as it encounters a tree, it is lifted up and it passes from that area and then goes away. Okay, so let's not get a feeling that the shelter belts will kind of absorb the pollution. Well, it does, but not to the extent that it can be said this is the major mechanism of the pollution control from the shelter belt is really not neither the absorption nor the filtration, but it just simply moves the air mass with the dust to the higher level and then it just disperses far away. So these are the various options people try. Okay, and the more engineering options are also there, but these are general little things, like you are nearby your shop where you have lots of dust. Well, what you can do is put a little bit of water all around if you have the water. I mean, and you don't need to have very high quality of water. Spread that around, and you must observe that the shopkeepers which are there, and because they are the one who's exposed so much because of the dust, because the vehicle is moving, somebody is moving around, and the dust. They on a periodic basis, what they do is the simple ordinary thing: put a little water around their shop and things like that. It gives you a little good smell, as well as it also prevents a lot of dust emission that can possibly come because of small things, but the important things. Sometimes the smaller options are better options and more doable in that sense. So what we will do is stop this discussion of fugitive emissions. This is everyone to observe, everyone to do something about this one, because they are significant, they are important, they cannot be ignored, and moreover, nose level and in the cumulative sense, they can be really a very significant and a large source. Okay, what we would do is, the idea is that we go to an industrial process, okay, talk about the industrial emission, and as well as in that industry, let's little bit talk about the fugitive sources, because fugitive sources, as I said, can occur not only in the urban area, but it can also occur in the industrial area. So we'll move to the industrial sources, and then what we are going to discuss is what we call as the thermal power plant. We all have seen the plants which are producing the power, and there are lots of environmental issues related to emissions which are through chimney, and the emissions which are fugitive in nature. So we'll move to the next thing, and I'll take help of the computer graphics to talk about that. Okay, now what we will do is talk about the industrial air pollution sources, and one of the major air polluting industry is the coal-based power plant. So we'll focus on coal-based power plant, and it's also important to study this industry as we are a growing economy. We are producing right now about 100,000 megawatt of power, or the installed capacity is about little over about 100,000 megawatt. And we also planning, because we all need energy and electricity, we also planning that this the government is planning that this capacity is doubled, something like 200,000 megawatt, a major effort that would be, and in the process, and the plan is by 2015 we produce, or we have the power plant capacity of generation about 200,000 megawatt. And it will be interesting to know that almost around 65%, of course this number can vary, 65% can be coal based, and rest can come from other sources. So the coal based power plant 65%, let's use that word here, percent, it will be the coal based power plant, because we have lots of coal and we want to utilize the coal for the power generation. Nonetheless, the issues related with the coal based generation are many, especially the air pollution thing. We all have seen the tall chimneys, and in fact in the country the tallest chimney that you see is from large power plant. You would see, you will be surprised, a power plant of 500 megawatt capacity will have a stack height, or the chimney height of 275 meters. So what I would do is that go through the process and try to identify the sources as we proceed in case of the coal based thermal power plant. So what we're going to discuss now is the coal based, as we call them, thermal power plant. So let's move to how the power plants look like. Okay, you see the little thing there on the top, how the plant works. So let's go through the process of the power generation. This is the baseline I'm showing. The first of all, you see a little thing which is coming on the corner of the screen is the bringing the raw materials that are required. Largely this raw material is a coal, and it can either come from the ship or from the mining area where the mines are, and through the railway wagons this coal is brought to the power plant. You would also see that immediately this coal which is there is dumped and stored, the coal storage. Okay, the next step in the operation is that there's some kind of coal storage and some primary crushing. Okay, if I can say here, primary crushing is done, and the coal is transported through the conveyor belt. What you see here, the strip which is going here is essentially the conveyor belt that will take the primarily crushed coal to the what we call as a bunker or as a storage of the coal. Then what we do from the storage of coal is further take it to what we call as the coal mill, because now we want to make the coal still finer. And how do we make the coal finer is to take it to the ball mill or the coal mill, and essentially most of the time it is a ball mill. You use huge steel balls and put into the large container, and the whole thing is rotated, and the ball is keep on falling onto the coal, and in the process the coal becomes very fine. So then once the coal is fine, almost of the size of, let's say, anywhere between 20 to 100 micron. So then now once the coal is sufficiently fine, because we are not talking a great deal about the combustion engineering, but what we are saying is that once the coal is powdered, or the technical terminology is from the coal mills, what we get is from the coal mill what we get is what we call as the pulverized coal. So this pulverized coal can be used now in the for the combustion or to obtain the energy. And how it happens is that what you can do is the coal from the coal mill, the outlet from the coal mill will go to the boiler, or this is the little firing area. What you see is and then apart from the coal, the air is supplied, and the pulverized coal burns very well, giving you the high temperature, high energy. And then what we do with this energy is to have a system of the water tubes. You can't see really very clearly here, but you can see here there are the tubes which are filled with the water, okay, and the heat that is generated from the boiler is the tubes which we all know. It's kind of a water tube boiler. So the water which is heated here, and then steam is generated and steam is passed through this area. So what you can say is this is the outlet of the stream as steam, as you will see here. So let's write this as the steam, so that is going out. Okay, then what happens is this steam goes and runs a turbine, okay, that you can see the turbine here with a steam jet hits to the turbine, and the turbine is rotated, and in the magnetic field what you get is the electricity, and it eventually is produced as a generator, as you can see here, the generator here, okay, and then you have the steam which had a lot of energy. After having done the job, the steam must be cooled down, as you can see here, and after how the cooling is done through the condenser cooling. So what you see is this thing is basically this is a condenser. How the condenser really works, because this also has the environmental issues. You take the surface water, or it could be the water from sea. So the surface water, suppose there is a river here, and then you are pumping the water, and then provide a large surface area, and this cool water, which surface water is relatively cool, comes in contact, not the water but the surface, which comes into the contact with the steam, and steam, as a result, steam will condense, okay, and make the water here, and this cooling water is in a closed circuit here. It doesn't come in the contact with the steam, is taken out and is disposed of back to the wherever the source which was there. So one of the issues here, what you see here is the surface water was, like, say, at some temperature T1, and by the time it has done the cooling operation, its temperature goes up, and this temperature becomes T2, and T2 minus T1, or we can call this as the delta T, is the rise in the temperature of the cooling water temperature. So this also causes what we know as the thermal